Good morning, students. In the earlier sessions, we learned about logic gates. Logic gates can be used to construct circuits that can perform binary addition and subtraction. These circuits are used in the design of the arithmetic logic unit, that is ALU in short. The electronic circuits are capable of very fast switching action, and thus an ALU arithmetic logic unit can operate at high clock rates. For example, the addition of two numbers can be accomplished within nanoseconds. Arithmetic circuits can perform 7 different arithmetic operations using a single composite circuit. It uses a full adder, FA in short, to perform these operations. A multiplexer, as we have seen in the earlier sessions, multiplexer is used to provide different inputs to the circuit in order to obtain different arithmetic operations as outputs. So in this session, we are going to learn about binary addition. So let's learn about binary addition. The most basic arithmetic operation is addition. The circuit which performs the addition of two binary numbers is known as binary adder. Okay, about the basis of binary addition. Numbers represent physical quantities. Always numbers are used to represent some physical quantities. So the table here shows the decimal digits and the corresponding amount of pebbles, here given as dots. So here the digit 1 stands for 1 pebble, that is 1 dot. 2 stands for 2 pebbles, 5 for 5 pebbles, 6 for 6 pebbles, etc. and so on. So addition represents the combination of physical quantities. For example, 2 plus 3 equal to 5. This symbolizes the combination or combining 2 pebbles with 3 pebbles. That is 2 plus 3 gives 5. That means we are combining the physical quantities 2 with 3. That's what we get, the total of 5 pebbles. So this can be symbolically represented as 2 with a plus symbol, again 3 pebbles equal to 5 pebbles. That's what we represent using the digital values 2 plus 3 equal to 5. The addition of binary numbers is done by adding the digits starting from the right side of the numbers, in the same way as we add 2 or more base 10 numbers. It starts from the right side and we add towards the left side of the digits. In binary addition, the place values are given as 1s, 2s, 4s, 8s, 16s, etc. So we first add the digits in the 1s column, then we move towards the left, that is add the digits in the 2s column and then the digits in the 4 column and so on. The only difference is that here we do regrouping when the sum of the digits becomes greater than 1. So the binary addition is similar to the decimal digits, addition of decimal digits, in that we start from the right side of the numbers and move towards the left side. But here the only difference is the place value in binary numbers starts from 1s, 2s, 4s, 8s, 16s, etc. As you know, binary numbers means it contains only two numbers, two digits, that is 0 or 1. So then binary addition also includes the addition of 0 and 1 only. Adding two or more binary numbers is one of the arithmetic operations on binary numbers or base 2 number systems. In binary numbers, as we said, in binary numbers we use only 2 digits, that is zeros and ones. In a decimal addition, when we add 3 plus 2, we get 5. Similarly, when we add their binary equivalents, we know the binary equivalent of 3 and 2 are 11 base 2 and 10 base 2. When we add these two numbers, 11 base 2 and 10 base 2, we get the result as 101 base 2, which is 5 in base 10. The result of both binary and decimal addition give us the same answer. The only difference is that the place values of the digits. The place values of the digits in binary number systems changes. So the process of this binary addition will look very familiar to you. The only difference is that the decimal number system, we regroup the next place value whenever we get the sum of the digits greater than 9. You know, in the decimal number system, when we add two numbers, if the resultant number is greater than 9, we regroup the numbers. We use tens digit from 0 to 9. But while adding the binary numbers, we regroup the next place value when the sum of the digits becomes greater than 1. So in decimal number system, we use regrouping when we get a result greater than 9, and in the binary number system, we use regrouping when we get the result greater than 1. So this is the difference between the addition of binary numbers and addition of decimal number system. So we regroup the next place value when the sum of the digits becomes greater than 1. As in the binary number system, only 2 digits can be used, that is 0 and 1. We use only 0 and 1 for binary number system. So I shall make this clear. See, computer circuits process binary numbers, you know all that. And binary addition is the key to binary subtraction, multiplication and division. So binary addition forms the basis for all the other arithmetic operations. For binary addition, we make use of 4 basic cases. That is the rules for binary addition. We must know about the rules for the binary addition. The simple rules. That is the first case, when we add 0 with 0, that is 0 plus 0, we know the result is 0 with the carryover 0. So when we add 0 with 0, we get the result 0. And when we add 0 plus 1, we get the result as 1. The third rule, when we add 1 with 0, that is 1 plus 0, also get the result as 1. And when we add 1 plus 1, this is the difference. That means we are using regrouping in this case. That is, when we add 1 plus 1, we get result as 0 with a carry over as 1. When we add 1 with 1, 1 plus 1 in binary addition results in a 0 value with a carry over 1. That means we must write the result as 1 0. When we add 1 plus 1, we will get the result as 1 0. Here 0 is the result and 1 is the carry over. Again, the fifth rule, when we add 1 plus 1 plus 1, we get the result as 1 with carry over 1. That means when we add 1 plus 1 plus 1, we get the result as 1 1. Here 1 is the result of addition and 1 is the carry over. We get the result 1 and the carry over 1. So these are the basic rules for binary addition. That is, when we add 0 plus 0, we get the result as 0 and the carry over is also 0. When we add 0 plus 1, or 1 plus 0, we get the result as 1 and the carryover as 0. When 1 plus 1 is added, we get the result as 1, 0. Here 0 is the result of addition and 1 is the carryover. The fifth case is when we add 1 plus 1 plus 1, we get the result as 1 and again a carryover 1. So we must remember all these binary rules to perform binary addition of numbers. Here if we discuss about more than one type of number, it may be helpful to use subscript for the base. As shown here, the usually used subscripts are, we use 2 for binary numbers, we use 2 as the base for binary numbers, 8 as the base for octal numbers, 10 as the base for decimal numbers and 16 as the base for hexadecimal numbers. So these are the usually used subscripts for denoting binary number, octal number, decimal number and hexadecimal. For binary numbers, we denote the number with a base of 2. For octal numbers, we use a base 8. Hexadecimal is denoted with a base 10. Hexadecimal is denoted with a base 16. See for instance, 1 1 base 2 represents a binary 11. 23 base 8 stands for octal 23. 45 base 10 represents the decimal 45 and F416 represents the hexadecimal F4. So these base number or these subscripts are used to denote the numbers. When we use more than one type of a number, we must make use of these subscripts. So that's all about the binary addition. If you can remember the 4 basic rules that we have seen already, the 4 basic rules for binary addition, you can add the column by column to find the sum of 2 binary numbers, regardless of how they may be. In first generation microcomputers, Apple II, TRS-80, etc., addition is done on 2 8-bit numbers such as A7, A6, A5, A4, A3, A2, A1, A0. So this by addition is done using these 8-bit numbers. For example, as given here, A7, A6, A5, A4, A3, A2, A1, A0, let it be the first 8 bits, and when we add this with another set of 8-bit numbers, B7, B6, B5, B4, B3, B2, B1 and B0, here the most significant bit denoted as MSB, most significant bit MSB of each number is on the left, and the least significant bit denoted as LSB, least significant bit, is on the right. As given here, for the first number A7 is the most significant bit here. As in this instance, A7 is the most significant bit which is on the leftmost side, and A0 is the least significant bit. A0, that is the rightmost bit, will be the least significant bit, and the bit given in the left side, leftmost side, will be the most significant bit. For the second number here, B7 is the most significant bit and B0 is the least significant bit. So I think it's clear for you. So you got a basis or a basic knowledge about binary addition and arithmetic circuits. So let's make it clear using a simple example. So with a basic knowledge about the rules of binary numbers, so how to add binary numbers? Binary numbers are used in computers to store and represent data using digits 0 and 1 that we have learned already. And there are two cases that come up while learning about binary addition. There are two cases of binary addition. The first one is the binary addition without regrouping, and the second one, addition of binary numbers with regrouping. We know in decimal addition, when we get a result greater than 9, we use regrouping in addition. In decimal numbers also, in usual arithmetic additions, when we get a result that is greater than the digit 9, we use regrouping. Likewise, in binary addition, when we get a result that is greater than 1, we must make use of regrouping. So, regrouping is not at all necessary for if we get the result that is less than 1. That means, in binary form, we can make use of zeros or 1. When the result is greater than 1, we must make use of regrouping. Let's see an example of that. Binary addition without regrouping. When the addition of two digit result in 0 or 1, then we don't need to regroup while adding two or more binary numbers. So, when two binary numbers are added, if we get the digit either 0 or 1, we should not, or there is no need to bother about regrouping. There is no need for regrouping. For example, here we are going to add 101 base 2 with 10 base 2. These are all binary equivalents of 5 and 2 respectively. So, let us see how will we add these two numbers 101 base 2 with 10 base 2. The first step in performing the binary addition is that write all the digits of both the numbers in separate columns as per their place values. So, this is similar to what we perform in decimal addition also, usual arithmetic addition. Write the numbers or write the digits of both the numbers in separate columns as per their place values, and here it is written as per their place values. Then the second step is start from the rightmost column digits. This is also how we perform addition in our usual arithmetic classes. Starting from the rightmost column, here the rightmost column is denoted as the least significant bit. So, starting from the rightmost column, here the given numbers are 1. For the first number 101, the rightmost bit is 1, and for the second number 10, the rightmost digit is 0. So, when applying the binary addition rule, here 1 plus 0 gives 1. We learned it from the binary addition that 1 plus 0. Here we add from the rightmost digit. So, 1 plus 0 gives 1, that is the result we obtained when we add the rightmost digit. So, hope it is clear for you. Starting from the rightmost side, we have to add the rightmost digit of the first number with the rightmost digit of the second number. Here 1 plus 0, the result is 1. Then the third step, move to the next column to the left. As in usual addition, we have already added the first digit of the two numbers and we got the result as 1. Now moving towards the left, the next numbers are 0 and 1. So, next we have to add 0 plus 1. We know and we have learned from the binary rules that 0 plus 1 is 1 again. Already we added the leftmost bit 1 plus 0, we get the result as 1, and moving to the left side 0 plus 1, again we get 1 as result. Now the fourth step is, in the last column we have only 1 left. So we can apply the rule as 1 plus 0 here. That is, only 1 is left here. So 1 plus 0. We get the result as 1. So when we add 1 0 1 with 1 0, we get the result as 1 1 1. There is no need of performing regrouping here because we get only the results of either 0 or 1. When we add these two numbers, in these two binary numbers, we get 1 1 1. That means if we get the result either as 0 or 1, there is no need for regrouping. But there may be cases when we need to perform regrouping. Let's see an example, adding binary numbers with regrouping. When the addition of two digits result in a number greater than 1, then we need to regroup while adding two or more binary numbers. In usual addition, we use regrouping when we get a result greater than 9. In binary addition, we use regrouping when we get a result greater than 1. Because binary number system uses only 0 or 1. So when this addition, when we perform binary addition, if we get a result greater than 1, we must regroup the numbers. So here see another example of adding 1 0 0 1 with 1 1 1. As we have seen in the previous example, first arrange the numbers as per the place values and then apply the binary addition rules. Here, starting from the rightmost side, in the first number, the rightmost bit of the first number is 1 and the second number is 1. So we start adding the digits 1 plus 1. As we have seen in the binary addition rules, 1 plus 1 results in 1 0. That means 0 is the result with a carryover of 1. When we add 1 plus 1, it results in 1 0. 0 is the result with a carryover of 1. 1 is the carryover. So we put the result 0 here and a carryover of 1. So the next step, moving on to the next left side digit, 0 plus 1. Already we have added the rightmost digit, that is 1 plus 1, and we get the result as 0 with a carryover of 1. Now moving to the next column, we have 1 carryover plus 0 plus 1. We know 0 plus 1 results in 1. But 1 plus 1 results in 1 0. Again here 0 is the result with 1 carryover. Then adding the next column. Again 0 plus 1 we know results in 1 with a carryover 1, that means 1 plus 1 again results in 1 0. 0 as the result and again 1 as the carryover. Now 1 plus 1, the next column. Moving to the next column, we must add 1 plus 1, that again results in 1 0. We have written the 0 here and the carryover must also be written here, as there is no more number left for addition. We write the 1 here. So the result of binary addition of 1 0 0 1 with 1 1 1 yields 1 0 0 0 0. So just remember the binary rules, then the binary addition is much easier, like your usual arithmetic addition in decimal numbers. Addition of binary numbers of when we add 1 plus 1, the result is 1 0. So first when we add the rightmost numbers of the binary digits, here 1 plus 1 yields 0 as the result and 1 as the carryover. Again when we add this column, 1 plus 0 plus 1, that is 0, 1 plus 0 gives 1, again 1 plus 1 gives 1 0 with a 0 as result and 1 carryover. Again 1 plus 0 results in 1, then 1 plus 1 gives 1 0 as the result, 0 is the result with 1 carryover, where the last column, addition of the last column gets 1 plus 1 equal to 0 as the result and 1 as the carryover. As there is nothing left with the numbers for addition, we must write 1 here in the result. So we get the result as 1 0 0 0 0 as the result when we add 1 0 0 1 with 1 1 1. I hope it's clear for you. Learn well. Thank you.